So this particular part, so this particular part, a to the n, n over 2n plus 2. Okay, so is that increasing or decreasing? Is it decreasing or increasing? Decreasing? So decreasing, that means your A2 is going to be less than A1, right?
1 and 2, no, they're the same.
They choose 1 and 2 are the same.
1, 2 are the same. That
And then after that, it's decreasing.
after that, yeah. So we're gonna talk about if it's 1, it's okay. But if you 1 go to 2, 1 go to 2 is the same, it's okay. But if after that, we say same is okay yesterday.
Yeah.
Okay, so same as
Yeah.
That's what I was
But only at the beginning.
No, it doesn't matter. It's just like thinking about XQ graph. XQ graph is going pause and then go up. So you still can have it inverse. You can have still stay at 0 and then go plus again. You are still monotonic. Does that make sense?
Okay.
Now, how do I prove that this is monotonic?
You can compare it. If you compare after A2 to A3, then it's decreasing.
I will do n plus 1. Huh?
Yeah.
No, you can that's calculus. That's on the textbook that you can use that. So you can use that. So you're gonna be n plus 1 here. So if it's n plus 1 over 2n to the plus 2, this one is 2n, sorry, this one's n plus 3, right? So this one is going to be less than n over 2n plus 2.
How's it gonna be less? Oh yeah. No, it's gonna be bigger. No, because it's equal. How is it gonna be?
Your next term's supposed to be smaller than the first term. So what you can do is you can cross multiply and you can switch those two places, right? So it'll be 2n plus 3 over 2n plus 2 is greater than n plus 1 over n.
Be greater than and equal to.
Greater than or equal to. So at this part, it's going to give you 2, right? It's greater than 1 plus 1 over n. This is algebra.
Why'd you make it n plus 1 over 2n plus 3?
This is 2 plus 1.
It's just the next thing
Plus
is
1
new.
plus the top and bottom. Why?
Because you're doing the next term, so it's n plus 1.
Oh, to see where it hits? Or where it
Because you know the next one will be decrease. Compares it to the next term.
Oh, okay. Understand that.
Is that okay?
Yeah, no.
So I move the 1 over, so be 1 is always greater than 1 over n. Is that true? Because n is going to be positive integer, right? So start with a 1. It's fine. 2 is going to be less. 3 is going to be even smaller. So it's always less than that. So it's always greater than. So this is a true statement. So if it's true, it's a monotonic. And then you're done. So let's just say that sometimes algebra way is better than the pre-calc way. It's very, very intuitive. If you just compare to the next term, if you see your next term is you think about it, n can only be positive number, right? So if you plug in 1, is that true? If you plug in 2, is that true? If you plug in 3, is that true? It's always true.
Did you decide to put the equal to sign? Or why did you decide to?
No, it's always the greater or equal to.
Okay. And
That's why we said talk about XQ. XQ graph you can have equal to, right? And then you're gonna go up again.
And then why did you decide to move those two numbers specifically?
Because I can simplify those. So A over B is equal to C over D. You can actually switch this in SAT question, you used to have this type of question. You can switch those numerator and denominator and still hold true. Because, or you can do cross multiply, you can do AD is equal to CB.
That it goes to one value.
Yeah, and then you divide, yeah.
Then you squeeze them.
You just skip a step.
So if this is nothing to do with squeeze theorem, this is true statement. If it's true statement, you're monotonic.
8, 9?
No.
No, that's 53.
That one, 53, Anthony said they're wrong, but I'm gonna double check again. Okay, I'm gonna double check what's the right way. I'm gonna get back to you on 53. But this one just monotonic.
How do you know if it's bounded? That there's no asymptote?
They are going to a 0. They're going to a 0. Oh, okay. You have early release? Late arrival. Oh. When's your surgery? Tomorrow? Is that okay for this particular question?
Bounded just means it fits in.
It goes to a value.
It goes to a value. Like limit x approaches something, it will go to the value. It will go to, and here on the bottom, it's gonna be way greater than.
For limit approaches non-divisor.
Oh, okay.
When would it not be bounded?
When it goes to infinity or negative.
When you go to infinity or negative infinity. Okay, so I'm gonna double check the 53 on the answer key, so I'll get back to you. But we're gonna talk about the next one. The next one is gonna talk about what is the partial sum, and we're gonna talk about telescope series. Okay, so first of all, let's talk about what's the difference between sequence and series. So sequence is the A1, A2, A3, dot, 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 dot. If a series is gonna be A1 plus A2 plus A3. So series means adding each individual term. And when you're adding each individual term, you can have converge or diverge as well. Okay? So what we're going to do is we're going to start with that. And we're going to start with what is a partial sum. So if I have, for infinite series, summation of n equal to 1 and infinite a to the n, the nth term, so nth partial sum is given by Sn is equal to A1 plus A2 plus A3 plus dot 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 to the all the way to the AN. And we say if the sequence of the partial sum, if the sequence of partial sum Sn converge to S, then, so if they converge to S, okay, they converge to some finite number, then the series summation of n equal to 1 to infinity, an, it converge. So if it converge, it will go to a definite value. And we can say the limit S is the sum of the series. Now, sometimes Sn, if Sn diverges, which is does not conclude into a value, then the series diverge. The series diverge. So it could be S equal to A1 plus A2 plus A3 dot dot dot. S equal to summation of n equal to 1 of infinite of an. So you can diverge on the series. Majority of series, I mean, it depends on what kind of series is.
Wait, what does that mean?
If the series diverge, so if you add up all the numbers, so like say 1 plus 2 plus 3 plus 4 plus 5, we know if we add to infinite, it's going to be infinite. But if you got 1 plus 1 half plus 1 fourth plus 1 eighth, that is approaching 2. So you can have a converged series or you can have a diverged series. Huh?
What's an example of that?
Is that what you
1 plus 2 plus 3 plus 4. So example, I'm going to give you the example. I have some example here. So I have some example here.
just comparing like
Series.
this one, if it converges,
Diverge.
because one has one fourth. I don't know what that's called.
So if I have a S3, that just means A1 plus A2 plus A3. So you stop at the third term. If sum at the third term, then you're just gonna be S3, and that S3 is equal to A1 plus A2 plus A3. So that will be the example. Okay. Now, for example, is this converge or diverge? Is it converge or diverge? Why? Yeah, because Sn is equal to 1 plus 2 plus 3 to a plus n. So if I keep on adding, right? If I make $1 today, $2 tomorrow, the day after, even though it's going slow, but eventually I'm still gonna be very rich if I grow like to a billion-year-old, right? It's not gonna be finite. It's gonna be adding each time, and each value you're gonna add it be bigger than before. Do you guys remember the formula for this one? This one we done with definite integral. What is summation of this kind of series? If something is I, do you remember that formula?
Put on the outside if it's like a
No.
constant.
Mm-mm. So it'd be n to the n plus 1 over 2. Do you remember this? When we do definition of integral, that is a summation of I. Summation of I squared is some other formula I don't even remember. But the summation of I is going to be n times n plus 1 over 2. Now, if you take the limits of this, right, n approach infinity, obviously you're going to n times n plus 1 to the 2. That's equal to infinite because it's not going to be defined. Because numerator, the bottom is the same, numerator keep on going, so that is going to be infinite. If it's infinite, then it's going to be diverge.
It being converged.
Oh, we're going to give you a few examples of a converge. Okay, so
Wait, is there other examples of diverge, or is it only like infinity?
it's only infinity is diverge. But if it's a converge, there's a lot of example.
It's numbers.
What if it oscillates like negative positive?
That's also diverge. Oh yeah, that'll be a second example of diverge.
Oh, okay.
But I don't think you're serious. You're gonna have oscillation. Oh, I guess you can. Depends on what kind of sequence you have.
Yeah.
But yeah, I don't recall which one it's gonna be. But we're gonna talk about some converged series. So this series here is very cool. In this case, in this section, we're only gonna talk about two series. One is called telescoping. And that's a very popular one. It's called telescoping, especially competition. If you go to competition, a lot of time series, because there's only two type of series can be evaluated sum. One type of series can be evaluated sum is geometric, and another one is telescope. Telescope series is like this. Now, the only way that you can try it out to see actually what happened. Now, let's just see what happened here if you plug in n equal to 1. What happened if you plug in n equal to 1? 1/5 minus 1/3. Yeah, so just plug in a value. And that's if n equal to 1, right? Can I plug in more? N equal to 2 is what happened.
1/7 minus 1/5.
Good. And I'm going to keep on going. I'm going to do 4 more times. What's the next one?
1/9 minus 1/7.
1/9 plus 1/7. Okay. And n equal to 3 plus 1. What?
1/9 minus 1/11.
1/9 minus 1/11.
No,
1/11 minus 1/9. Thank you. And it will go to infinite. But something's gonna happen here. You're gonna see something that is start crossing out. Okay? Eventually, all this term just gets smaller and smaller and smaller and smaller and smaller. It will be completely crossing out. It will be completely crossing out. So roughly, we can estimate that it's gonna be probably what?
Negative 1/3.
Negative 1/3. Eventually, it's equal to negative 1/3. Because they are gonna cross. Each term is the term is gonna cancel each other. And they will cancel out completely. But I'm gonna actually show you the work to get to that. The work to get to that is we're gonna assume that, so this is a 1, this is a 2, this is 3, this is n equal to 4, right? We're gonna show you the assumption of what happened. If n the term before, 2 terms before the n is what? 2 terms before the n is gonna be what? n minus 2. So I'm gonna write down n minus 2 here, and I'm gonna write out in term of term. So it'll be, if that's gonna be 1 over 2 to the n minus 2 plus 3, right? Minus 1 over 2 to the n minus 2 plus 1. Now, obviously, you don't need to do this. Just kind of show you what happened. This is n minus 2 plus, what happened if n equal to 1? N equal to 1 is going to be what? 1 over 2 n minus 1. Sorry, n minus 1. Is n minus 1 here? So 2n minus 1 plus 3 minus 1 over 2 m minus 1 plus 1. So that's n equal to 2, n equal to 1. I substitute into the formula. And I can simplify that in a second, but now eventually I'm going to get to n, right? Eventually I'm going to get to n. So the n is going to be 1 over 2n plus 2 plus 3 minus 1 over 2n minus 1. So that's n. Now what happened is this one, I'm going to simplify it nicely. So I'm going to just erase this part. So can somebody simplify this for me? For this first part? It'll be 2m minus 4 plus 1 is what? 2m minus 1, right? Does that make sense? This one's going to be 2m minus 3. And this one's going to change to 2m plus 1. Is that okay? And that's equal to 2m minus 1. Now I'm going to use Dipping Cutter to cancel them. So this eventually cancel out with this, right? Just like before. That's the pattern.
No. It would cancel out with the.
Oh, sorry. You're right. It's going to cancel out with this one. Use Dipping Cutter. So this is going to cancel out this one. And what else you can cancel? 2m plus 1 is going to be this one.
2m plus 3.
2m plus 3 is not going to cancel out. 2m plus 1 is going to be this one here. Oops, the icon's so too big. Is it this one? What else you can cancel out?
That's it for now.
2m minus 3 will cancel out too.
No.
Oh, actually, no.
2n plus 3 was later on.
2m plus 3 is only one left over. Hold on a sec. 2m minus 1 cancel out. 2n. This one is 2m. This one's 2m minus 1. Sorry, this one's 2m minus 1. So this one's gonna cancel out, right? 2m. Oh, this one 2n's minus 3.
You had originally.
Oh, sorry. I'm looking at the wrong thing. Okay. So eventually that it's gonna come down to only this specific term right here. And that it's gonna have that 1/3 in the front, so it'll be negative 1/3 and plus 1 over 2m plus 3.
Did you continue? That would cancel out, no?
Yeah,
If you continue, that's gonna cancel out from the term before. So the second term is gonna cancel the term before. So
Just leave 1 over 2
it was 2m plus 3.
Keep going back.
minus
2m plus 3. This one.
how?
Because this one's gonna cancel from before. That's gonna cancel from before. This is one. That's the only one term that's left. It's 1 over 2m plus 3. And then when the length approach infinity, that's gonna give you negative 1/3. Now, of course, you don't need to know all that, but you're gonna see that this term is gonna cancel from before because all the second term is gonna cancel from the term before. So the only thing that's left over is this one term, but this one term is not going anywhere. But since n is gonna go approach infinity, that is eventually that is gonna go to 0.
So you're saying this is like the proof?
Oh,
Yeah, we don't need to know this. We just need evaluation. What'd you say?
In the end, we'll have first term?
Yeah, you will have this negative 1/3 because everything cancel out, right?
Yeah, but like, when you have n, there, when you have n, you start with like first term.
Yeah, so this term had nothing to cancel with. This specific term has nothing to cancel with because you don't have the term after that to cancel with this term. So this is the only one left. No, negative 1/3 from here.
Two separate series.
Okay, so let me say that again.
Mr. Ye, can I have a
Yeah.
question? Actually, you explain first and then I'll.
Okay. So eventually, visualization, you can probably see that there is only one left over here.
Yes.
Yes.
There's one left over there. So I'm gonna cancel 1/5 and this one, right? And 1/7 and this one, right? And 1/9 with this one.
Yeah.
So eventually the second term, this second term is canceled from the term before from n-3. So that is gonna cancel out because of that. This 2 is gonna cancel out. This 2 is gonna cancel out. But this one has nothing. 2n-1 is gonna cancel out. This is the only one term left over. If that one term left over, it doesn't matter. You don't have to understand this part. But that one term left over is going to infinite. And so that's still gonna go to 0 regardless.
Instead of starting at 1.
Isn't that gonna cancel out with the next one though? Just like when we did.
No, but we stop at n. We stop at n. Because a to the n, we stop at that
Oh, you're going
term.
backwards? Wait, no.
Where did one there come from?
1/3 from before.
n-2, can that give you like a negative value?
What do you mean?
So how you putting like n-2?
Yeah, think about there was a finite term, right? There was an nth term, and there is a term before that nth term. It will be n-1, and the term before that will be n-2. Of course, there is term after that. It will be n+1 and n+2, but we're gonna stop at a to the n because that's what we are stopping. We stop at n.
Well, the problem with doing that is that if you go as low as n equals 1, and you can't subtract 2, because then you'd be negative.
Well, no, but n is not negative.
What's the highest one?
n is continuous positive.
Okay, yeah, n is still positive. But n.
Well,
Why is 1/3 significant? Like,
if you
wait,
wait,
1/3 is the final sum.
No, I understand. But can you go back to like the original, the top? Yeah, that the 2n+2. Then you take out the 2. Wouldn't it be like? Wouldn't the series still work? But it wouldn't be
that's
1/3 this time.
Which 2 are you gonna take it out?
Both 2s.
You cannot take out a 2.
Why not?
yeah, the wind velocity.
Like 1 over.
He's saying if it's a different question and there's no 2.
Like,
Oh.
why is a series so significant over like if I
Just an
just
example.
It's just they have to be specific things. There's only certain things that go into telescope series.
oh it's a type
It's
of
the height.
series.
It's a
That's what
type of series.
Oh, okay, bro. I thought this was the one. I don't
There's a lot of different types. So I will show you the second type. Second one. Okay, I will show you the second one. So imagine that second one is this.
Is it different one? This is telescope?
Yes, this is also telescope, but you have to do some manipulation.
Telescope part 2.
So yeah, you can
Okay, so this is a telescope. However, in this form, it's not telescope
yeah, if you're trying to
because telescope usually has 2 separate terms. So can we use something that we know to make it 2 separate terms?
like when you're trying to find the maximum.
Not factor. Well, you have to factor first, but what is that called? Not difference of a square. What? Partial fraction. So can you do partial fraction of this?
Yes, you can.
And after the partial fraction, you're gonna see. Now, right now, today, we're only gonna focus on telescope. And I think we're only gonna focus on telescope because we're gonna run out of time to geometric. Because geometric is a very important thing I'd rather cover tomorrow. But today, we're just gonna focus on telescope.
So what's the other?
This one is a telescope.
So what was the other one we did?
The other one is telescope.
So they're both telescope.
They both telescope, but this one is invisible telescope. It's not invisible. It's like it's hidden. It's hidden
Okay.
because it's not showing 2 fractions.
It's like kind of
Okay. Alright, I got you.
like hide and seek.
And you put a over 1 that actually be over here.
Yeah, and then find out the velocity. Does it depend on acceleration?
Yeah, it's not.
So yeah, so all you need is this is velocity graph, right? So you just look at the blue. Like if the blue is positive, it's velocity. negative, then plus. It's decreasing.
I mean, last year I just explained like negative 1/3, and I didn't stop. I didn't go into the extension of what happened to the end.
That's your personal growth.
No, yeah.
I have to grow each year. Like I say, it takes 5 years to grow. I'm on the mid level.
Yes.
I'm on 3rd year.
Wait, can you go back to the thing again though?
So,
I'm asking, where did
It's
that
actually
green 1/3 at the bottom come from? The negative 1/3.
From original negative 1/3 before. The whatever.
How is it original if that's just the broken down version of what's on the top?
If I plug in actual m value here, right here, is the only value I have left because everything's gonna cancel out.
Isn't that the series?
Yeah, but you have to also understand what happened when it goes infinite. What happened at the end? Right now, ideally you can get an answer just a finite value by looking at the first 4 terms. But I want to see what happened to the end, like the end term, and also see the end term before that, n-1 and n-2, and see that this one is kind of hard to see, but this is canceled from the term before. That one is the hardest one to see, but everything else is gonna be canceled like this and canceled like this, I think, and canceled like this, and then this is only 1 term left.
Okay.
This is a final term left. I never tried to explain the second part. This is the first time because I think one is just stuck in that easy part.
Are you recording?
I think so. But I don't think I do a very good job because you guys are confused.
no, it's fire.
I mean, I just said first or second part, like I'm kind of.
Because the initial.
What's 2 times?
Why did you do?
The initial condition.
Why this with the way like
No,
negative
when
1/3?
Yeah, why do you do +2? Or
Because this negative 1/3 is cancelled out from before, right? All the things cancel out. And all the things cancel out except this term. But you still have to imagine this term approach infinity. We know that this is going to go to smaller and smaller and smaller and eventually it becomes insignificant. But this is where the insignificant part. The leftover is 1/2n plus 3. And that 1/2n plus 3, you need to reach infinity in order to see that's equal to 0. But this is the only term that's left. But we still have to limit and approach infinity to add up to the total sum. Maybe I should never explain the second part. But
maybe.
but some of you guys understand, that's all that matters.
Then what are you approaching when you do it the first time in the red to get negative 1/3? Infinity, right? Wait,
Dude, that's okay.
Can you do
Escúchame, por favor. It's going to infinite. But at the first 4 terms, I already see that it has a negative 1/3 left.
Okay.
But imagine you keep on going.
Yeah.
To prove that n approach infinity, those terms no longer matter because at the last term, this is if you reach infinity, it's a to the n. It's all the way to the last term.
Okay.
And that's the only thing that I have left.
Okay, I get it.
Now, that's if we go to infinity. But this is the last term, but n's going to approach infinite. So therefore, that's going to go to 0. You still have to take account into the negative 1/3 at the beginning because you're still adding. You still continuous adding. You're not going to stop until n reach the n.
So you have to show this on a test.
Yes and no.
No.
But if you show me, I'm appreciative. But if you don't show me, I'm okay with it.
How many terms should we show?
Look at it. You will look at a competition question. They're just going to ask you this series and they're going to ask you the sum. That's it.
Multiple choice.
Yeah, it's multiple choice.
That's different.
But on AP exam, they never ask telescope series for that far. They only ask multiple choice. So you don't need to understand this part. But it just show you that part at the end eventually becomes insignificant. 1/2n plus 3 is not going to be significant if you go to infinite. I seem like I'm yelling.
Yeah.
I get it.
But I thought I yell, you will understand more.
Yeah, I think it's wrong.
Don't worry about the space part.
Did you finish?
Yes.
I need you to finish.
Don't worry about that.
You gotta ask. Ask Kevin and Maddie what Maddie's supposed to know what she's doing.
Did you get to?
I know how to do it. Oh, no, I don't. I think it's that's my problem in the test. I know how to do it. Oh no.
That's good for mental health, right?
No.
Yeah, I think that's what I saw.
It should be mental health time right
His
now.
doctor's like 6 period long. I'm like, excuse me, did I hear that right?
Okay, I'm not gonna go to geometric, but do you guys figure out the answer for this one?
Yes.
Oh, we're supposed to do it?
Yeah.
Let me just make sure I'm right. I'm just listening to you.
But what will be the last term though? Can you figure out what the last term?
The last term?
The term you have left over at the end. What will be the SN term?
Oh,
What will be the last term there? That the term left over. For last one was 2n plus 3. 1 over 2n plus 3. Right?
Oh, like this. Find the term you think that. Oh,
You want us to find it?
You see if you can find it. It's not necessary. I will not ask you on the test.
wait.
But see if you can find it. I'm not yelling.
Yes, you are.
Maybe you are.
You're not your children.
Oh, it is over.
Ben said the video is rendering.
Yeah, you told me already.
This question?
I didn't know if you heard me or not.
Yeah, I did. Thank you.
Which one? Wait, which one? Compare my question. I have it. Oh, I got that one right. First try. Let's go.
So do you guys know how to do partial fraction?
wait, well, how does the square system work? Like when you do like ax plus c, or like ax plus
You don't need to do ax plus c here.
That's only if you have like an x squared in the
You have both linear factors,
No,
just a.
I'm just saying if.
Oh,
How did that work?
if it's like if your factor was like 2n squared,
Okay.
then you could do
Well,
or
ax
a
plus b.
yeah, or yeah, like whatever your first.
Yeah.
If it was like 2x squared minus 1 times 2x, then the x squared you have to do right?
If you have like third degree, you have to worry about. Second degree, because you're gonna factor it, they both gonna be linear factor. Shall I show you work or no? Okay, 4 over 2n plus 1 and then 2n minus 1 is equal to a over 2n minus 1 plus b over 2n minus 1, 2n plus 1. I multiply both sides by 2n plus 1 and 2n minus 1. So that's going to be 4 equal to a times 2n plus 1 plus b times 2n minus 1. Is that okay? N can first equal to negative 1/2. If n is negative 1/2, you are left with what? 4 equal to negative 2b?
Yeah.
B is equal to what?
Negative 2.
Negative 2. Okay, so that's why you need to know partial fraction, because you might need it used for a different reason. Now, n is equal to positive 1/2. Then the second term is going to go away. So you're going to get 4 equal to 2a. A is equal to 2. Got it so far? It's my eyes flip over.
Yeah.
Got a little too heated.
Okay, so now instead of write that, we can write down summation n equal to 1 infinite 4 over 4n squared minus 1. That's equal to summation of n equal to 1, infinite. 2 over 2n minus 1 minus 2n plus 1. If you write out the first few terms, you're going to see it. So what's the first term? 2 over 1, right? Minus, what's the second term? Not I mean the first term, but the second part. 2 over 3. Okay, plus, what's in the next term? 2. So 2 over 3. And then what? Minus what? 2 over 5. And I'll just do one more. N equal to 1, n equal to 2. Then that's going to be n equal to 3. N equal to 3 is what?
Negative 2 over 7.
2 over 5, right?
Oh, I'm flipping.
Minus 2 over 7. Is that okay?
That's a change.
And the dot, 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 dot. Now you can see the simplifying. I'm using different color to show you. This one's going to simplify this. This time it's going to simplify this. So now you see the orientation of simplification is kind of different. Do you see that?
Yes.
So let's try.
Jay, is that second part negative 2 and plus 1?
Yeah. Negative 2. Because b is negative 2, right? Yeah. Because b is negative 2. So you see that this is going to cancel out with this, and this cancel out with this. So you see the way it cancel kind of different order since last time. So let's imagine that if you have n minus 1 term. Can you tell me what's n minus 1 term? And give me a simplified version though. 2n minus 3? Is that right?
Yes, indeed. That is.
Okay. And minus 2n minus 1. Now you remember this term is cancelled from before. Right? Because all the term is cancelled from before, right? Now let's say it's going to be n. N is what? Well, we already know the n. N is going to be 2 over 2n minus 1 plus 2 over, so minus 2 over 2n plus 1. So this term cancel out, right? Is that okay? Now what happened? You have this term and you have this term. So limits n approach infinite of 2 minus 2 over 2n plus 1. But this one becomes insignificant, so that is equal to 2. This one's better because the way cancel is like one after. The other one's the first one, and the other one's the other way. So the gap is different. I don't know if you see what I'm saying. All right. That's it for telescope. Mental health. Let's play ping pong. No, I'm just kidding.
You want to teach us about mental health, Mr. Yang?
2 over 2.
Help my mental
No
health, Mr.
comment.
Yang.
No comment.
2 and minus 2 minus
Real question. How does the 2 over 2 and minus 3, how does that?
Huh?
How does the 2 over?
Cancel from the term before.
If you do n minus 2.
See this?
Cancel.
This cancel from the term, the first part of parenthesis cancel the parenthesis from before. So this cancel with when n minus 2.
What's the point of finding that one?
No point, just for fun.
Just for fun?
So much fun.
Discuss?
Yeah, because if you first figure out first 4 term, you see that patterns going.
Like, I understand. You
The
find-
whatever rest of them has to go smaller and smaller, and that becomes eventually 0.
So I find 2 because that's where it's converging at.
Yeah, because they go to infinite, it's gonna go 2.
But it's getting small, okay? And then,
But if it's not infinite, then it's gonna be something
it's
else.
gonna be a small number close to 2.
It will be closer to 2. But how close?
I don't know.
So we're playing ping pong now?
But also,
That's the only thing you care about?
And so I don't need to worry about that.
You don't need to worry about the second part. So even on math competition, they just gonna give you a question like this. They say, hey, find sum of the series. You're gonna be like 2.
Ah, okay. I see where
Because they don't care about the rest term, because that term is gonna go to infinite, and that term bottom go to infinite, it's still gonna go to 0, regardless what happened. I'm still yelling.
got it.
What's the homework? People gets passion. Which is called.
Passion, yeah, I guess. You can call it that way.
Can you put the homework now?
Yeah. No, I'm gonna finish geometric before I post homework.
Oh no! Oh,
That's
really?
yeah, that's great.
Thank you.
Carlos, you have one last question.
But I'll give you a geometric one here.
Sure.
I mean, I don't need to give you.
It's mental health right now.
Carlos.
Please, like,
You want my mental health to go down?
it's supposed to be an 80-minute mental health, and it's now really of 10
No,
minutes. So it's like 60 minutes. No, it's 40 minutes.
It's
Oh.
been
Or like,
It's not 80 minutes, like 5 minutes of mental health.
It's good for your mental health. Talk about number, go to infinite.
45 minutes.
a class time.
Yeah.
And then it's an 80-minute class. So 85 to 45.
Like the bounds. Great, 35 minutes of mental health. Math is hard. I don't know what else is. Wow.
What's in my nails?
Your nail?
Hell no. What?
But you have to break it up and prove it every time you do the problem, right?
So what's that question? 9.1, right? 653? Section 153, right?
No,
I wanna
yeah,
see
50,
the-
wait, 53. That question. Yeah.
Oh,
You get 3 over 8.
Yeah.
they convert. So they compare 1 over 2n. Anthony, are you sleeping?
Anthony. Oh, he said it. 53. You're supposed to compare it. I think
You compare 1 over 2n.
I know, so I was trying to figure out.
It's always less than 1 over 2n.
I like
Is that what you did?
not really. They kind of broke it up into like each multiple terms. They broke up the exponent into multiple. Well, that makes sense because
Really good. Oh, Mr. The competition on the 17th, where is it? In February?
I haven't decided if I'm going yet. It's like King. Temple.
What time?
Huh?
What time?
9. You had to be there at 9, so you had to wake up at 7. I don't know if I want to go to King at 7. I'm not. I mean, if you guys want to go, I'll go.
How
with
long?
you. 1 hour and 10 minutes.
Okay.
I don't. The thing is, I don't want to drive. If somebody drive me, okay.
Yeah.
I don't want to drive.
I'm not gonna go to the tennis match that day. It's not a big deal.
But I had to register now. I only have 3 days to register.
Okay, so it's a I'll let you know. It's gonna be. I'll let you know.
February 1st. You missed.
Okay.
I would probably rather go to Gainesville